Hello everyone. So today we have a session on linked list and we'll commence the session in a couple of minutes. It's I guess by 8:33. We'll wait for 3 minutes for a couple of people to join and then we'll start. So the topic that we're gonna discuss is linked list. And for any doubts, please you can ping here or interrupt the moment you want. Feel free to ask all your doubts. Cool. A minute more and then we'll begin our session. Okay, so we'll begin the session now. My name is Rajdeep Singh. I am a software developer and I'm in this industry from past 4 years. Currently, you can consider me to be an SD2 or senior software engineer, however your company or your stats might call it. Giving a rough introduction about me, I have been a computer enthusiast since my childhood, and developing apps, websites have been like an integral part of my day to day activities. So, talking about my career life, I have worked for startups, I've worked for companies like even Amazon, where I have led major part in the Fire TV. You might have heard about the Fire TV, the smart TV by Amazon. So consider turning on the Netflix or changing any brightness to the splash screen. All these things were done by my team. And how to get into these companies like Google and all, the basics is DSA, data structures and algorithms, because this does not just help you crack a particular problem statement, but it helps you in order to solve any life problem. For example, if I tell you I had a problem statement that, let's say in Japan, the number on the keypads are mentioned from 1 to, in India we all over the nation it's 1 to 9, but Japan says it should be done from 1 to 12. If you just Google it, you might find how Japan TV works. So how do you map things? So data structures, how do you do things efficiently, algorithms. So it's the crux, and every good engineer, especially software engineer, needs to have the skills. So whether you are joining as a SD1, SD2, SD3, DSA would be like the basics. They will ask you, they assume that you should have all the knowledge about it. And yeah, this is just about me and talking about the courses that we're going to talk about over here in Geeks or Geeks, the ones that I'm going to teach you. So it starts from very scratch, the basics of DSA, like what is DSA, arrays, linked list. We're going to move up to trees, graphs, by dynamic programming. And trust me, slowly and gently, these things might sound very big to you, like, oh my God, dynamic programming, what is it? But ask my students, ex students, so once they have been in my lectures, they see that, oh my God, the lectures are so simply defined and propagated that it gets into your brain. And there's a core to it. After my lectures, you need to understand that only my lectures won't help you. Even YouTube videos might help you. The normal, so many people do that, right? But in order to grasp everything, you need to practice. Just like maths, this is something that you need to practice every time, because computer science will help you grow everywhere. So yeah, enough of introduction. So today's topic, as we have discussed, it's linked list. I'm gonna just share my screen and we're gonna talk about what linked list is, how it goes about, and we're gonna talk about a couple of questions. So Hi, is this session okay? So I see Divya has a doubt. Hi, is this session for experienced people only or for students? It's for both, Divya. So whether you're an experienced person or a learner, like for English, for particular topic today that I have chosen, we're gonna start from scratch. So if you feel that maybe you know about what a English is, how things are stored, maybe you can just listen to me, and slowly and gently we'll move forward to tips and tricks how to go about doing things. Okay, so I'm just sharing, and I think I won't be able to get these messages while I'm teaching. So you can unmute yourself and maybe speak, or I'll after every 5-10 minutes I'll try to come back to the screen so that maybe I'll see what comments people have. Okay, I'm sharing my screen. I think it's visible. So the topic that we've chosen for today, it's linked list. Okay, and the question that we're gonna do, the reason why I've already mentioned all these things is, so if you feel that you're comfortable with linked list, you can already start with these questions. One would be middle element, how to find, given a linked list, how to find the middlemost element. Kth last element, given a linked list, kth element from last, you need to display that. Sum of two numbers, let's say two numbers, let's say 981 and 124, these two numbers are given such that these form a linked list. How do you add these two number and return the number as a linked list? This is one of the questions that we're going to discuss. Then odd even linked list, reversing a linked list, and the main and the best problem is LRU cache. This is something that was asked to me in my Amazon interview. Not exactly LRU cache, but even a higher modification of it. But since LRU cache was something that I'd already practiced, so it was very easy for me to crack it over there at that very moment when I saw the question. Okay, so coming to how to go about doing these questions, right? So in order to do these questions, you need to understand what is a linked list. Okay, so today apparently I don't have my pen and pencil connected right now because of, in a hurry. But usually I keep a pen and pencil with me with my iPad. So today I'm just gonna do it with my mouse, but on the same software over here. Okay, so the topic that we're gonna discuss is linked list. Okay, now what is a linked list? Linked list is a data structure. You need to understand this. What is a data structure? A structure which holds some data. Now let's say we have some data. The traditional method of storing, let's say, a list of numbers or a collection of some items is, the answer is array. This is what we usually use, an array, to store numbers. How do we store numbers in an array? Let's say we've got numbers like 1, 3, 7, and 9. These are the numbers that we have stored in an array, right? So let's say now I ask you, can you add an element 8 to the array? Somebody might answer, yes, sir, I can do it. I would ask how. They'll say, sir, I'll create another array of size, whatever the size is given to me over here, plus one, and then I'll add one last element over there. Cool, that's fine. But if you see internally what happens, this was the space that you are taking in the memory, right? You'll deallocate the space, you'll create another space, and then you'll add it again. So how much, first of all, you're taking extra space. Next, the time that you're spending is, you're iterating through all these elements. That means, let's say the number of elements is n. So an addition of just one element is taking you an operation of order of n. So even these terms, like what do you mean by order of n? If I say the our time complexity is big O of n, what do I mean by this? So don't worry, when I said when you join this Geeks for Geeks entire course by me, we will teach you how asymptotic notations, how do we arrive at seeing any code, you'll be able to tell, okay, this is the time complexity of this particular problem. But you need to wait for that particular lecture to come and join me. Till then, I'm assuming that you know what time complexity stands for. Okay, so I told you this was a problem. But what if I want to add an element in a constant time? That means it should just take order of one operation that I want to do, because I'm just adding one element, right? Why do I want to iterate through all them? Let's say there are only four elements here, it doesn't matter. What about, let's say there were almost 10k elements and you had to add just one element? That doesn't make sense choosing an array, right? So array is a data structure which helps to store numbers. Or why were these numbers? Because when you define, let's say you are using Java, then you would have said, okay, I'm defining it as an int. Let's say the name of the array is a. You define the square brackets, right? You write an equal to sign, and then whatever. Let's say you're writing it in Java, it's going to be new int and the size of the array. But remember, the size is mandatory to be given, right? Let's say the size was given here to be 4. So this size is mandatory to be given. But for linked list, this is the flexibility what linked list will provide us. Now coming to the main topic, which is linked list, how linked list helps us. So in order to tell you what linked list, how it works, let's understand one particular thing. In computers, we have got something called as a heap memory. Okay, heap memory. This is where these data are stored. For example, when I'm saying I want to store this array, I will be storing this array in contiguous memory location. So basically, this is the heap memory, and it has got various memory locations. Okay, so whenever I say I want to add these elements in an array, they'll be stored in contiguous memory locations. Let's say it's going to be stored like 1, 3, 7, and 9. So if you see, these are being stored in contiguous memory locations. Okay. So that's why like we don't need anything extra. So whenever we have to store, and this size is already predefined the way we have said. But when it comes to linked list, what happens? It allows us to dynamically select any particular location and then add it. So what happens when we want to add this particular new element 8, we can add it anywhere. So let's say rather than 1379 being stored in an array, let's say we are storing it in a linked list. How will we store it? What is the syntax? We'll discuss about this later, but let's just understand what a linked list actually is. So when we are storing this in a linked list, so it will be stored anywhere. I'm using red color for linked list right now. So let's say 1 is stored here. Okay, 3 might be stored here. Let's say 7 is stored here. 9 might be stored here. And let's say if you want to add another element. Okay, before adding another element, let's say now how will you connect these two elements, these all elements, right? So what happens, all these memory locations have an address associated to it. Let's say we name address as a, memory address as a. So a, so for here in array, what happens, these are in contiguous. So we know that since the size of a particular array element would be fixed, let's say we are defining it as an integer, right? It might be 4 bits or 8 bits, so depending on the processor, so we can transfer it to the next one, and we know that's the next element. But what about the linked list? So in linked list, what happens, let's say, let me just add one page here. Okay, so now in linked list, what we'll do, let's say I have 1 over here, right? I have 3 here, I have 7, and I have 9. Okay, so now let's say I want to traverse these elements. How am I going to do that? Because after 1, I don't know where 3 stands. So this is where what we do, along with the number, we also keep something called as a pointer. In the people who are comfortable with C++, they might understand the pointer concept, or you can just understand for other languages like Python or Java, you might understand it the way of next address. For example, if this is an object, we'll be storing the address of this particular object, so that I know, hey, okay, 3 was pointing at, so apparently let's say this is a1, and the address of 3 is a3 a2, let's call it a2, then this will store a2. So what was the missing concept between 1, 3, 7, and 9 in English? This was the missing pointer which it could lead me. Right. So this is what we do. So in a linked list, we store 2 things in a particular object. One, the value itself. Now this value can be anything. It can be a string. You can store your name. For example, I can store Karan. I can store Rajdeep. I can store a character, a single C, A, anything. I can store a double or even an object. Like let's say there's an object called a student. Okay. So we can even store that object, but along with whatever we are storing over here, we need to store one more thing, which is called the pointer to the next element. Similarly, this 3 will be storing, let's say 7 had the address of A3. So this will store A3, so that now I know, okay, this is connected over here. So I am really sorry for this. So, okay, this is connected. And similarly, this will store A4, where A4 is actually the address of my 9 element with value 9. Okay. And now this last element, since we don't have any other element, right? So for C++ people, you can understand this to be as a null pointer, or in Java, we can just call it null. So a few terms that you need to remember for linked list. The few terms are the first element. Okay, the first element is called the head of the table, not the head of the table. I'm sorry, it's called the head of the linked list. And the last element, it's called the tail of the linked list. You need to remember these terms because they're gonna help you name your variables very well. And remember, when you're coding for a good interview, like man, whenever you're writing the code, right? Don't name your variables like string s, char c, int a, b. Try to name it as per the question itself. Let's say the question revolves around student, so it should be student 1 or student a. So this will help because when you're right in the industry, right, you can't use variable like abc because there are n number of classes, n number of files, so repetitions will happen. So you need to be very specific with a variable naming. And this is something with the interviewers, me, when I used to interview students, I used to see that how they're naming the variable. So that's a very big point to be included. So yeah, this is called the head, this is called the tail. So this is the rough idea about what a linked list is, how it looks like. Now let's perform the operation for which we actually started, that why do we want a linked list, right? So let's say we want to add a number 8. Okay, so what we'll do, we'll create a object 8, we'll add it any, we'll ask the computer to add it anywhere. Let's say in the heap memory, it adds it here. And obviously the, let's say the address is a5 for now. So what we'll do, in this last, in the tail, we'll just remove this null. Instead of null, we'll add a6. Okay, and we had already created this 8 object, right? So now this 9 will be pointing to 8, and there's just one thing missing. What is it? This pointer needs to be mentioned as null again. That's it, done. You have already created a linked list and it just took one operation. Why? In order to add an element, what do? You just change this pointer, you add it to the new address, and you mentioned it as null. So this is why linked list comes into handy. Now coming to real life examples, where are these actually used? Okay, so let me tell you a few things where we can actually use linked list. Number one would be stacks, because if you see stack, what happens in stacks, we are adding elements and we are removing elements, right? So linked list comes handy over there. Then we have queue. Even a queue operation does the same thing, where we are adding elements and we are removing elements. So stack as a data structure or queue as a data structure can hold like variable amount of elements, right? Not like a array where it's specifically told. So these are the two applications where you'll find in computer science. Now talking about real life example, if I talk about a real life example where you can actually see linked list working in place is a browser. Now how is a browser using linked list? Let's say you've opened a particular tab and over there you have mentioned, let's say, GeeksforGeeks.com. Now, after opening Geeks for Geeks, you move to the linked list section. From linked list section, you move to a question as find the middle element. From find the middle element, you move to practice. Now, what happens? This is a chain that was created. Now, at any time, you can go back, and then you can go forward, and you can go forward as well, right? So, this is where a linked list is used in real life. Now, you might ask me one question that, sir, you told that, okay, we can move forward in a linked list because we have these pointers moving forward, but how do we move back? How does browsers handle that? So here comes the next picture, which, so this linked list that we have created, it's called a singly linked list, SLL, where the direction is only one, it's a unidirectional thing. The second comes is a doubly linked list, a DLL. So what happens over here, along with forward pointers, we have got backward pointers. So how is it implemented internally? So just imagine we're going to have two pointers this time. One was pointing to the next element, one more pointer will point to the previous elements. So we know that one had an address of a1, right? So this will store a1. So if anybody can guess what this will store, 7 will store the address of 3, which is a2. So now we can go backward as well. And just for a quick test, what will the head first pointer store then? Correct, it's gonna be null. We're gonna store null. Why? Because we don't have any backward connection to it, right? So this comes the doubly linked list. Now this third type of linked list as well, which is called the circular linked list. Now circular can be, how can it be implemented? So if anybody is correct, instead of this, the head's first pointer points to the tail, and the tail's last pointer will point to the head. So this way, there's a circle that is created. So there are three types of linked lists that are actually implemented in real life and in computer science where we're going to use it. So this is a rough idea for those who had no idea what a linked list is. I hope it was easy to understand. So let me just see if there are any questions. Then we'll move forward with the basic questions. How to iterate over a linked list? We'll see the basic syntax, and then we'll move forward for the questions. So okay, cool. I see there are no questions, so maybe we can move forward with this. So if let me just add a particular text element here. Okay, cool. So now how to represent a linked list? So basically there are two kinds of things which you need to understand. One is a class and the other one is a struct. Now struct is actually a structure. Okay, so you can say structures are usually defined using it's a value type and class is a reference type. So basically what will happen, in order to store a linked list, we need to use either of these. Now how can we store it? Let's say, what do? You say class, just ignore if there's any caps up and caps down because of the so we have class, let's call it a node. Okay, and now what will happen, let's say I'm talking about this particular linked list. In this linked list, what are we storing? We are storing in a value. Let's say we are storing the value as integer. Let's say value, and then we'll store one more thing which is called a node next. I'm talking about a single linked list right now. Okay, so this is a class that I have defined. That means this is a blueprint of my particular linked list element. So that means every node that I had created, remember, it had a value and it had a next node pointing to the next element, right? Now instead of this, you can put anything. If you want to put a string, if you want to put a predefined class as student, you are free to do whatever you want. So you can define, okay, you can do one more thing. Rather than just defining one, you can do multiple things. You can define, okay, double, I want to do multiple things, so I'll say double v2. I can also say a name, a string n name. So if you see properly, what are we doing? The object that we wanted to define, we can store n number of values in it, right? Even these three can be encapsulated inside a class, and then that can be put over here. So it all depends on your implementation. What do you want to do? So for the example's sake, we'll do the way we are doing. My class node contains two things. This is mandatory, that you have to store the next element. Why? Because we just noticed, right, in order to move to the next element, we need the location for that. So if I would just ask you a question that, okay, how would you implement a doubly linked list? So the answer should come as, it should be node pref. That means we have a next pointer and we are having a previous pointer. So every node has a previous and a next. So let's keep for simple just the next pointer. Okay, now let's say you have a class main. Okay, and over here, I'm writing it in Java right now, so you guys can define it the way you want it. So I'm writing public static void main, and let's say now you want to create a linked list, right? So how can you create a linked list? You can take input from the users the way you want it, but I'm just showing you a basic structure. How can you do it? You'll say node, let's say n1 equals 1, and then, sorry, I'm really sorry, it should not be this. Let's say I write the value, and there should be one more thing which is called the constructor, where you will say node, because you're defining the node, right? And let's say I'm asking it the value, you will say int val, and I'll just define two things over here. This dot val is equal to val. So what will happen, whatever I'm going to pass the argument over here, it's going to be assigned to that. So in my public static void main, let's start, I will start it like node n1 equals new node. And I think people know that if we call the new keyword, it's going to instantiate an object by calling the constructor over here. And let's pass in the arguments, and I'm passing, let's say I want the value to be 1. Okay, once this is done, so my node n1 is created. I'll create another node. into, I'll define the value to be as 3, the way we are doing it, right? And now I have to connect these two, right? So how can I connect these two? I can just call it like n1 dot next should be equal to n2. Boom. So having done this, so if I just, cool. So if you see it properly over here now, what did we do? We defined a particular structure that we wanted, right? So this is the structure for my this particular node that I was creating, right? And in my main class, what did I do? I defined a first node. So what did this do? This created a node for me with a value 1 and a next pointer which does not have any value. And since it does not have any value, it is taking the default value as null. Remember this. Then I created another node n2 with a value 3. So this will create another node with a value 3, and obviously the next pointer would be null, as we all know. Cool. Right till now, these two nodes are not linked. They are just nodes. They're not linked list. When did they become linked list? When I wrote this particular line that, hey, n1, you're next. No, it should not be null. You should be 3. So this is how I've just connected these two things. Okay. Now let's let's say I have to create another element. Okay, so I'll just do one thing, text edit. Let's say another element. How can I create? I'll say node n2 n3 is equal to new node, and then I'll assign the value to be 7. Okay, and the last node that I had to create, it was n4 is equal to new node, and I'll assign the value 9. And we know that I had to write n2 dot next equals n3, and n3 dot next is equal to n4. So once I create this, let me just add it over here so that things are in front of everyone. So once I do this, you can just take this to be an extension of that. After doing this, we have this entire linked list, the one that is mentioned in the red, to be created with us. Okay, now let's say I want to iterate amongst these elements. How can I do that? So it's a very simple thing. I'll just show you what you can do. You can say that since we know that this n1 could have been named as one more thing. So since we have written n1, this was a very static allocation that I have done, right? Usually what we do, we just create first element, which is called the head. So this n1 is usually called the head. Okay. And the next elements we created dynamically. But for the simply sake, let's consider that we are doing it this way. Now what we'll do, we'll first check while, let's say, while head is not equal to null. Okay. Or let's say if you don't want to change what head is, you can just say node temp is equal to head. That means you are assigning temporary value to head, so that whenever you want to retrieve head, you can retrieve head. Okay, so you're just saying that, hey, while temp is not null, that means I have at least one value in my linked list. Okay, so I'll just say printf or println or console.log, whichever language you're working in. I'll say temp.val. Okay, now what I'll do, I'll say temp equals temp.next. So what this will do, basically, this particular line, this temp.next, let's say I am over here, right, in 1. So the value of temp was 1. I said, hey, print in my console, 1 was printed. Then I said, hey, temp.next. What was temp.next? It was 3. So initially, my temp was, let's say, standing here. After writing temp is equal to temp.next, my temp moved here. So my temp is no longer here. Okay. The loop ends. I'll come back here. Is temp null? No, it's not null. So again, it's going to print 3. Then again, it's going to move to next. But over here, let's say it is null. So it will stop. So when it will come, hey, it will say, hey, temp is already null. So my output is printed. So this is how a basic iteration in a linked list can be done. Okay. So any doubts so far? No. Cool. So let's move to the question that we had discussed. So let's say, given a linked list, let's say the question given to you by an interviewer would be, hey, Karan, so let's say you're given a linked list and you're supposed to display the middle element. How will you do it? So given this example, let's say this example, you need to display the middle element. So the middle element would be 7. Why? Because 1, 2, 3, 4, 5. There are 5 elements. So this element comes out to be the middlemost element. So what could be a solution? a brute force solution with, so this is how you need to always go. So remember, whenever you are in an interview, right, in an interview, your solution should go from brute force to a better one to the best one. So now what happens? It could happen that these could be clubbed together. That means there is only one better solution than a brute force method. That's fine. But usually the trend goes like you first give the most layman terms solution to the interviewer. Obviously, the interviewer won't ask you to implement that. He'll ask you to improvise on your solution. Once that is done, so you can give a better solution. So, given this question that given a linked list, display the middlemost element. So the first thing that the brute force solution that would come to my mind is, okay, what I will do, since in an array I could know the number of elements, let's say I could know 5, I could divide it by 2, and then I could directly retrieve the middlemost element. But what about a linked list? I can't do that over here, right? So I need to first get the count of the linked list. So let's say I will iterate amongst all the elements. How will I iterate? I can simply do like while temp is not equal to null, and then I'll say, hey, I'll count plus plus. I can store a variable like count equals 0 initially. And so what will happen initially? Temp was at the first place, right at the head. It's gonna move, and one more line is remaining, which is temp is equal to temp dot next. So what will happen initially? The temp was at head. So it is not null. It will store make the count to be 1. Temp would be move to the next element. Temp is not null. Count 2. Third element count. So this way till the time I'm reaching to the last element, I'll get my count. So this way, after iterating the entire linked list, I get my count. Let's say my count comes out to be, after the entire loop, my count comes out to be 5. So what I can do, I can divide it by 2 to get the middlemost element at this spot. And then again, I can run a loop, a similar loop where I'll count that, okay, I'll skip these many elements. The moment my value comes out to be 2, I'll display that. Brute force solution works. So if I give an implementation over here, how does it go? Initially, my temp was here. So I've already got my count to be 5, and I said I want to do it by 5 by 2, taking it like 2.5. So what I'll do, I'll move here. Okay, fine. Then I'll increase my count. I'll come here. Then I'll increase my count. The moment I see, hey, I've reached the middlemost spot, I'll just return this element, right? Cool, the solution works. You have given a solution. So this is called the brute force solution. That means even a layman could have come to this solution. But if you see the time complexity, what was the time complexity of this particular solution? So let's say currently there were only 5 elements, but what if there are a crore elements, or let's say a billion elements? So you would have gone like a 1 billion, 1 billion plus half billion, right? So that counts to 1.5 billion, right? This is the count that you would have gone, correct, in order to get to the middlemost element. But there's a better approach. The better approach comes with using 2 pointers. What are the 2 pointers that we are going to use? This is the solution that we're going to move over here, and this is something that is used in most of the solutions in English, which is called the fast and the slow pointer. Okay, now treat it this way. Let's say I've got 2 of my pointers, both are pointing over here. Let me just change the color. Okay, let's say my first pointer, which is fast, and the other pointer, which is slow, both are pointing here. What will happen? In every iteration, my slow will move once and my fast will move twice. So let's say in other iteration, my fast comes, my slow will come here, and my, which color was that? And my fast will come here. Okay. And in third iteration, what will happen? My slow will come here, but my fast will directly go here. So what is happening? My fast is taking twice the speed of reaching. So if you just try to close your eyes and imagine this happening, by the time my fast pointer will reach the end, my slow pointer will reach the middle. So in this example also, you can see by the time my fast reached the end element, my slow reached the middlemost element, right? So take any length of example, this will come true. So this is the concept of slow and fast pointer, where you take 2 pointers, and you move one pointer at a normal pace and the other pointer at some extended space. So over here we are moving it twice the space, because what happens, showing the middlemost element means half, the size should be half. So that's why, since that half ratio was there, that's why we are moving the other pointer to be twice the speed. So what happens, by the time we reach end, the fast pointer reaches end, slow pointer reaches the middle. Okay, so let's do it this way. Let me just open middle element of linked list. Let's solve this question quickly. Okay, solve this problem. Okay, so let's say, okay, so this is the Geeks for Geeks portal where you can come here, enjoy, read the problem statement properly, go through the code, right, choose the language of your type, and see what are the test cases and what this usually does. It shows you the company tags as well. So let's say you want to know, okay, what are the companies which are asking this kind of question, right? You can just open and you can see, oh my God, Wormware, Zoho, Flipkart, Morgan Stanley, Amazon, Microsoft, all these companies have asked this question in the past. So you can get a rough idea of what level of question that you're trying to solve right now. Okay, so let's say I'll just go to the question once again. Given a head of the linked list, so my input would be head. The task is to find the middlemost element. For example, if this is the array that is given to us, the answer is 3. Why? Because if we see two elements here, 3 is the middlemost element. Now, if there are two middle elements, they have also given a discrepancy resolution that if there are two middle nodes, that means the number of elements is even. Return the second element. That means, let's say for 1, 2, 3, 4, 5, 6, I need to return the fourth element. Okay, so internal representation, you can just go through the various examples that we have given. And expected time complexity, they have said order of n. So let's see how we can do it. Okay, so starting off with a solution that I had given you, fast pointer and slow pointer. Okay, so what I'll do, I'll first create a fast pointer and assign it to head itself, and I'll also create a slow pointer and assign that also to be as head. Now what I'll do, I'll see, I'll I need to iterate my slow and fast point, right? How long I need to iterate? Till the time my fast reaches the end. Okay, so that means my condition that I want is that, hey, fast is not equal to null and fast dot next is not equal to null. You might ask me that, okay, sir, why did you use this? You'll come to know in a second. And how did I know that next is an element? If you see here, it's already mentioned that, okay, remember the way we were doing it, it's means we had used val, they've used data. That's totally fine. Okay, so this is the condition that I'm checking. While my fast is not equal to null, my fast dot next is not equal to null. So what I'll do, I said my slow moves once. So I'll say slow is equal to slow dot next. And I said my fast will move twice. Now, how do I move a pointer in linked list twice? It's going to be fairly simple. Fast dot next. Fast dot next will give me a node, right? Now, let's say this is a node. Let's call it A. So can I write A dot next? If I can write A dot next, why can't I write this dot next? So this will give me twice the speed, right? So if you can see, for the first time, slow is at 1, fast is at 2. Slow will move to 2, it will move to 4. 3, 6. 4, 8. So that's how you can see, by the time I reach 1 billion, my slow will only reach half a billion. Okay, so once this is done, what did I tell you? The slow will be at the middlemost element. So if I just do return slow dot data, I didn't say val because over here I need to see its data, and the return type of my solution should be integer, and it's already mentioned as integer. So this is how it should go. So let's see how it goes. There might be just one thing. Let's say there is no head given to it. That means the head was null. And since I assigned my slow to be head and slow dot data, so if I try null dot data, this should give me a null pointer exception, right? But it is mentioned that it's gonna have at least some value with us. So in that case, what you could have mentioned that, hey, if head is equal to null, that means there is no value provided to us. You can ask the interviewer that, what should I return, sir, if there is no linked list given to it? Should be 0, it should be -1. This is a concept of question you can ask your interviewer. Okay, a healthy discussion round, the clarification on that should happen. Okay, for now, we're not including it. Let's compile and run and see how this code works. Okay, let's submit. Cool, it passed all the test cases. So you should try always this, that whenever you're trying to solve a particular question, try to solve in a particular editor itself. This will give you a sense of confidence that, hey, I, even if the number of attempts you take is more, maybe there are some syntax errors that you make, but still, if you see this 100% test case passing, right, it gives you confidence and it will help your motivation reach to a next level. Okay, so any doubts so far? Anyone related to whatever we have discussed so far? No doubts? Okay. So this was one of the questions we can do. Now let's come to the next question. Next question is kth last element. Okay. So let's say you're given a linked list and you're supposed to display the kth last element. So just a hint for everyone, this would be something similar to what we had done using middle element. So let's first discuss what the question is. Let me just open and let's search for kth last element. Okay, it says nth last element, it's fine. Okay, so let's say this is the question that is given to us, and if they say 3, so 1 2 3, you need to output 2. If they mention 4, 1 2 3 4, you need to mention 30. So it's like the kth last element from previous. How are you gonna do this? So let's read the question first. Okay, so we are given a head of a linked list and number k. So the input that we are given are k, which is the number of elements from end that we need to display, and the head of the linked list. Because okay, so in order to represent a linked list, only one thing is required, that is the head of the linked list. Why? Because this will help us propagate to every other element, right? So if you're given a head, that means it's more than sufficient. Cool. So, given a linked list, the task is to find the kth node from the end. And if k is more than the number of nodes, okay. So, remember I told you about the clarification question that you need to ask your interviewer. This is something. Okay, sir, what if the number of elements is 5 and the k is given to me as 7 or 8 or whatever, more than that? What should be the output then? So, it will be told to you. The interviewer, trust me, me as an interviewer, I was really happy when any student was asking me that, okay sir, what is this possibility? Because this is where I come to know that, okay, the person is trying to put himself in that zone of the question and is trying to understand every possibility before jumping into the solution and before writing the code. Trust me, code, even normal people who have just done a BCA can easily write it. But in order to be a good developer, in order to be a good software engineer, you need to first use your brains, right? Because let's say you have written an entire code and you understood the problem incorrectly, there's no point of giving that solution, because that solution is giving you a wrong output. It's not giving you the output as you expected. Okay, so the clarifying question was that, okay, what if the number of nodes is lesser than the value of k? What should be done? The output should be -1 in this case. Okay, so for internal representation, it's mentioned that, okay, you can go through this. So we've done with the examples. So what is the brute force approach that comes to anyone's mind? It would be something similar to what we had thought about in the middlemost element. That means, okay, we'll go to the last element, we'll count how many number of nodes are there. Let's say there are 100 nodes now, and let's say the value of k is 5. So that means 5 from 100 would be 95. So I need to move 95 spaces ahead. Again, I'll start from my head, I'll keep on moving till the time I reach 95, and I'll display that, right? So if we talk about the time complexity over here, it's gonna be a billion. Let's say there were a billion records, a billion, and then a billion minus k. So that's a lot, right? So what is the better approach? Again, we come back to the one that we were talking about, which was the fast and slow pointer. So okay, fine, Rajdeep sir, but you had already told that fast will move twice and slow will move once. But how we are gonna manage this time? Remember, I never mentioned that it should be a normal and a double pointer. We called it a slow and a fast pointer. The pace of the fast pointer would be depending on the question. So in this particular question, since we want to move k spaces before. So let's say there are two players. Consider it in this way: there are two players. If I want that this player should be winning by a meter of 100 meters from this player, if and their speeds are equal, if I move him 100 meters ahead in the initial stage and then they start moving together, by the time this reaches the finishing line, this will be 100 meters behind, right? This is the concept we're going to use over here. So initially, before moving them together, we'll move the fast pointer k spaces ahead. That means it would be k spaces ahead. Okay, so that means this is the fast pointer, this is the slow pointer. K has already, it has moved k spaces ahead. Now every iteration we'll move them together. By the time my fast pointer reaches the end, reaches the tail of the linked list, my slow will be reaching the k minus, and like the number of linked lists minus k. So if you guys have understood, it's fine. If not, let me just write the code once and I'll explain you once again along with the code. So as you mentioned, we need 2 pointers, right? We needed node slow, which would be initialized as head. We need another one like a fast, again initialized to be as head. And what I tell you, before moving them together, I need to move my fast k spaces ahead, right? K is already told to me. So I can just run a loop for int I is equal to 0, I less than k, and I plus plus, and I need to move my fast pointer, right? So I'll say fast is equal to fast dot next. Okay, so this finishes off my fast moving ahead. Don't worry, we'll consider that particular consideration, that what if k is more, we need to think that okay, what fast dot next is null, and next time I'm trying to do this next dot next, it won't work, right? So you can just add one more check condition over here that hey, we'll see. We'll talk about this checking of the condition in the end. Till the time, let's solve the most optimum solution in the beginning. So we have moved fast k spaces ahead. Now we'll move them together. And how will we come to know that we have reached the end? It's the fast pointer which will help us. And how will the fast pointer help us? Once it comes and reaches null. So I'll say while fast is not equal to null, because the moment it reaches null, I know that hey, I found my answer, which is slow. Okay, so while fast is not null, I'll say fast is equal to fast dot next, and slow is equal to slow dot next. Okay, so what did I tell you? Once this is done, I need to return the value which is from the slow. So I'll just say return slow dot it's written data, right? So slow dot data. Okay, now I'll show you. If I run this question, it will go for a couple of cases, but we'll fail in a few cases. Why? Because we haven't handled this particular situation where k is more than the number of nodes. Okay, let's say what if k is more than number of nodes? How will we come to nodes? So let's say there are 5 nodes and k is 7. So if I'm trying to make fast reach 7, it will reach null, right? So we will never arrive in this particular code. We will have a null pointer exception here itself. So in order to do that, we'll just say, hey, if fast is double equal to null, that means we have reached a point where we cannot move forward. So I'll just say return -1, because this is what the question asked me for. So let's just quickly go to the code and test how it works. Okay, ready for evaluation. Okay, it's expected as we wanted. It should pass. Yeah, it passes all the test cases. Cool. Now I'll just show you what if I remove these two lines. What is the difference that would be created? If I try to submit, it will pass a couple of test cases, but it will fail. See, it is passing. It failed. Why? Because see, the number of the value of k was 5, but we are given only 4 elements. So that's why we had to add this condition over here. And if you see properly, right, I was reading the question along with you. And how did I arrive to the solution? Just by talking. And this is what interviewers actually expect. When you are giving your solution, if you just noticed one thing, I was writing the code and I was explaining everything to you. I don't think so that I need to explain anything in this code right now. Why? Because you already understood. You are following along with me. And this is the feedback that I had received from one of my interviewers. I was interviewing for Meta. That's when an interviewer told me, I after writing the entire code, I told him, sir, I'll just explain you whatever I had written in the code. he praised me. He said, "No, no, Rajdeep, you don't need to explain me the code, because while you were writing, you were explaining it so well that I could follow everything." So cool. That's a very big praise to have in an interview, right? So you need to develop this habit while you're writing the code. Try to just, even in your head, or if even any YouTuber on internet, if you see, if he's posting a coding video, while writing the code, he'll speak everything, right? So this is a practice even you guys should implement. So just for simplicity, we'll just complete this and see how it works. Obviously it should pass. Okay, any doubts so far in this question? Anyone? No. Okay, cool. So cool, now we move to the next question, which is sum of two numbers. Okay, after this, maybe we'll have a short session of discussion how to get about cracking interviews and all, maybe for a 2 minute session, so that you guys can have a break as well, because I know everything getting all at once, it becomes really hectic. So let me just search for this particular question, which is sum of two numbers of using a linked list. Okay, it's called add two numbers. Okay, if you see 563, which is the representation of this number, 842, which is the representation of this, the resultant should be 1405. How do we do that? It's simple. If you do add these two elements, you do this, but you need to represent this as a linked list. Now, the number of problems that you might arrive while thinking about this problem is: number one, we were given three elements in the linked list, right? But the result contains four. Now this is also dynamic. Since it was the last element, if I see it's 5 and 8, so that's why we got a carryover, right? So it became 14. But what if it had a single element? So you need to have a discussion over there too. The next thing could be something like, what if carryovers are present? What if there is no number? What if there are like five nodes in a particular linked list and only three elements? What are you gonna do? What if the numbers are how is the zero represented? So these are the clarifying questions which you should ask your interviewer before even jumping to a solution. Okay, so let's see the question once. Okay. So given two numbers, num1 and num2, represented by a linked list of size n and m represent respectively, the task is to return a linked list that represent whatever we have discussed. So for example, 190 would be represented as 1, 9, and 0. So why is that null actually shown? It's like the next pointer to 0. And 25 is represented 2, 5, and null. So whatever example that I gave you, the number of elements in each of the linked lists are different. How are you gonna tackle that problem? So I give you some time, think about the solution, and maybe you can go through this question, and then we will come back to the code. Not just code, I'll explain you how did we arrive at this particular solution. Okay, think about it. Given a linked list, given two linked lists where each linked list is representing a number, it can be of anything where every element is representing a digit particularly. You need to return the number of elements that we want. So, okay, this fast and slow pointer, I think we are done with this. We don't need fast and slow pointer anymore. So the thing that we want to do is add two numbers. Okay, now we need to add two numbers. So we have, let's say, 2, 7, and 9. And the other thing is, let's say, 7, 3, and 2. So you need to go to your traditional method of adding elements. Remember in childhood what we used to do? We used to write the numbers, units, place, tens, hundreds. So you need to go back to your school level and then proceed. So how do we do? 9 plus 2. So we have two things you need to consider. One is the sum, other one is the carry. Sum and carry. Carry goes to the other one. Sum is the one that we actually want. So 9 plus 2, the value of sum becomes 11. So the sum becomes 11, where 1 is the sum and 1 is the carryover. Okay, so 1 is the sum and 1 is the one that we have carried it forward. So 7 plus 1 is 8 plus 3, which is 11 again. So we put a 1 here and we put a 1 here. So 2 plus 1 is 3 plus 7 is 10. So the sum becomes 0 and the carry forward is 1. Since there is no element over here, so this is a solution that we come. And you need to display it this way. Okay, so think about a solution for this. So I've given you the rough idea that we need to consider sum and carry as things. We need to display this as a linked list. Okay, and think about it. Okay, so if people haven't gone through this particular thing, so let me give you a few hard things that are going to come in this question. Number one, this 2 was given and this 7 was given to you as heads, right? So this is head 1, this is head 2. Okay, so did we add in this way? No, we added in this way, right? Because you can't do like 2 plus 7 is 9 and then 7 plus 3 is 10, 0 1 carry over and then 11. No, this is not the answer, right? Totally changes the entire complexity of the question. So another hint that I've given you, think about it more. What else can you do? So we can traverse this way, but we need to traverse it this way. Okay, if you are thinking of reversing a linked list, that means if 279 is given to me, if I can somehow, if I can convert it into 927, that means 9 and then 2, sorry, 972, and the other one to be 237. And then if I start counting, because if I make this head 1, this head 2, 9 plus 2, 11, 1, 1 carry over, and then 2 plus this will give me 1, 1 carry over, and then this will give me 0 and a 1. This can work. But then again, I need to reverse it. Why? Because this time this is the head, but then this is the head. So one solution could be you can reverse both the linked list. So you can come to this, and when you come to the solution, you can again reverse the linked list. But before that, you need to know how to reverse a linked list, right? There are other solutions to this problem as well, but thinking about the most brute force solution, this is the one, right? So if you guys have identified it correctly, we need to learn how to reverse a linked list. Like now, there's a nice saying. There was a particular developer from YouTube, so he had to resign his job because he was not being paid well. So he applied for another company, which is booking.com. When he applied over there, he was rejected. Even if he had an amazing experience of developing applications and his computer science skills were top notch, he didn't know how to reverse a linked list. So yeah, trust me, reversing a linked list is something to be proud of if you know how to reverse a linked list. Okay. So before jumping on this question, let's first see how to reverse a linked list. Okay. So let's say I'm given a linked list 1, 3, 5, and a 9. Okay. So let's say this is the linked list, and the output that I expect is should be 9, 5, 3, and then a 1. For simplicity, you can consider that the next is null. Similarly, over here, I want this to be as a null. Okay, so this is the problem statement that is given to us. We are given two particular linked lists. Sorry, we are given a linked list and we need to reverse it. And the sample is given to you on your screen. So how do you do it? So let's not waste time allowing you to think about it. Let me just directly jump to the solution. So what do? We basically take a previous element. Okay, let's say currently my previous is there, and then I'll take a current element. Okay, these are the two things that I need to consider every time: a previous and a current. So what will happen? So currently, let's say my current is equal to 1 and previous is not pointed to anything. So what will I do? I will say that, hey, and then I need another pointer which is next. Let's call it nxt, not a next, because you might get confused that, hey sir, even this is called a next, why are you confusing? So we are calling prev, cur and a nxt. So how can you get prev? If you talk about the coding things, you can simply write it this way. You can say node prev, you can say node current is equal to head, and then you can say node next, sorry, nxt is equal to cur dot next. So this way all these three would be defined. Okay, let me just copy this and bring it over here for everyone's simplicity. Okay, let me just increase. Great. So this is what we are doing in the initial phase. That means we have these 3 pointers. Now what I do, I will say, hey, cur, your next, make it to be brief. Okay, so the code goes like this. Hey, cur dot next, sorry, yeah, cur dot next should be equal to brief. This is what I'm writing right now. That means, so this pointer is removed now. Remember, if I say cur dot next, when I write this line, cur dot next is equal to prev, cur dot next, which was this, I changed it to prev, and prev was null. Remember, prev is null. So if you see it properly, I have already achieved this particular task that I wanted. That means one next is prev. Okay, cool. The next thing, I will say prev, you become cur. That means I say, hey, prev, you come here. Okay, I'll say, hey, cur, you become nxt. So cur comes here. And I'll say, nxt, you go to curs next. So nxt comes here. Okay, in the code, if I will quickly write it, how will it go? I will say, prev, you become cur. I will say, cur, you become nxt. And nxt, I had already written nxt is equal to code dot next. So that's what I'm going to copy it over here. And I'll just take these particular code lines, and if I'll just add it here. Cool. So what did I do? If you see it properly, I basically said, hey, previous, you go to cur. Cur, you go to next. Next, you go to curs next. So that's how we have achieved this. Great. Now what will I do? I will again say, hey, so prev is no more here. This is null, remember. So once next is null. So now I'll again say, hey, cur dot next should be prev. So cur dot next, so this would be removed. This would be assigned to prev. This was 1. Okay. Again, I will remove these. So prev will go to cur. Now prev comes here. Okay. Cur becomes my nxt, and my nxt becomes cur.next. I have done nothing great. I have just used these lines and initiated with these lines. So I said cur.next, you become prev you become cur you become nxt, and nxt you have to be cur's next. So if you see properly, if you see these lines, 3 1, we have already achieved this. Right. Again, we'll do this cycle. We'll say, hey, cur dot next should be prev. So cur dot next, which was this, I'll remove this. I'll make this to be prev. Okay. I'll say, hey, prev, go to cur. So you become cur now. Current, you go to nxt and nxt. Sorry, this is cur. I'm really apologies for this. So this becomes cur. And cur's next would be nxt. So nxt comes here. Okay. Cool. Now, if you notice properly, if you see this, we have already achieved this. Now, again, same. Cur dot next, which was done. I remove this and I make this. Okay. I say, hey, prev, you become cur. Prev becomes cur. Okay, cur becomes next. So cur comes here. And this line, okay, so now this would have given a null pointer exception, but I've taught you how to deal with null pointer exception. You can just add a check that, hey, if that is equal to null, don't move forward, right? So, cool. Now, if you see properly, 9, you have achieved whatever you wanted. And what are you going to return? Let's say you wanted the head, right? So, if you want the head, you can just return the previous. So, after writing this code, if you just say return prev, you've got the new head of the reverse linked list. Whatever the size of the linked list is, if you just follow these two things, 1 and 2, obviously you just need to think the reason why I not mention everything at once. Why? Because I don't want to spoon feed you guys, because I've seen this with my previous students. If I try to spoon feed someone, they don't go back home and practice, and if they don't go back home and practice, they don't understand anything. I am ready, I am here for you to explain the code 100 times. I'm ready to explain you this logic 200 times till the time you don't understand. But I want everyone to at least go home and practice, because if you don't do that, it's not going to stay in your brains. Okay, so this is the way of reversing a linked list in a very simple. You might have heard that, okay, you can do this, but this is the actual procedure of doing this. And trust me, this concept of previous, next, and cur will be used for many other questions for linked list as well. Okay, so any questions so far? Where did this go? Any questions so far? Anyone? Nope. Okay, so if I just give you, okay, so if this is done the way I told you, we've already passed the lecture for 1 hour. So I'll just give you a quick small break. The small break would be not of like going away from the screen. You have to stick to the screen. I'll just show you like how my classes usually look like. Okay, so let's say, okay, so how to go about doing things, right? So we'll talk about bits, like how bits are there, like negative numbers, twos, complements, how to code things. We'll talk about arrays, find the second largest element, removing these things. And the best thing, I like after every class, it's my habit to give you a cheat sheet that, okay, this was the thing that was done, but if you do it this way, it's a hack. So trust me, it's like my USP that I usually give. We'll talk about recursion, like reverse and array. Trust me, dynamic programming, trees, graphs, all these things, they crave recursion, because these things are incomplete without recursion. They're nothing without recursion. So when it comes to recursion, I'm gonna give you such tips and tricks. I know today many of you're scared to write any recursive code. Why? Because it involves a lot of logical thinking, because there are only 3 lines of code that you have written, but in the background a lot of things happen, how a recursive stack, auxiliary stack space is taken, how things go. We're going to discuss everything, and trust me, the way the hack that I have developed over the years, I'm going to share the same ones with you. And as per my ex students, you're gonna have a really easy time understanding this. We're gonna talk about backtracking, how Sudoku solver works, even like a 9 queen problem. Okay, and okay, see, if you see clarifying questions, this is like a very big thing you need to understand in any interview. You need to ask clarifying questions. If you don't do that, I'm sorry, it's a tough time for you to get through that interview. Okay, we're going to talk about sorting, how sorting works, like various kinds of sorting algorithms. Okay. We're going to talk about questions, the very famous question, number of islands and all. We're going to talk about strings, what reversing a string feels like, reversing, finding a maximum frequency, and then even how hash map helps in solving string problems. What's a string builder? What's the time complexity? Why is a string stored as an object? Why does C consider a string to be an array character? So everything would be balanced parameters. This is a very famous question asked by Google. Okay, then language we talked about. Then we're gonna talk about things like trees. Like, okay, when we come to trees, remember before starting trees graphs, we'll be done with the basic topics like recursion, arrays, and all. Why? So that once we are in this topic, you will be not confused, and you don't will want to go back and read about, hey, I need to use recursion here, how will I use recursion, right? So trust me, we're gonna explain everything, and we're gonna solve n number of problems, because Concepts you can learn anywhere, even from notebooks. Even a YouTuber can explain you, right? But over here we are there to make you solve questions and explain you in and out, like why did this work. We don't want you to mug up things, because engineering or software development is not something to mug up. Trust me, it's something to understand. It's what logical development is like. Okay. And if I talk about Mang specifically, right, let's say there are every interview, there could be a series of 3 to 5 interviews, technical interviews, that you have to go. And every interview will have 1 or 2 questions. Okay, let's say the interview is of 1 hour. Okay, let's say 5 minutes goes in introducing yourself, how are you and all, and the last 5 minutes or 10 minutes are for clarifying questions, right? Okay, do you have any feedback for me and all that things. So 2 questions, you have only 40 minutes. That means 20 minutes for 1 question. Simple maths. Now imagine in 20 minutes, you need to read, you need to ask clarifying questions, you need to think, then you need to code, then you need to write the time complexity, space complexity. And if the interviewer is not like, he didn't understand a code because maybe while writing the code you did not explain it well, you need to show him a dry run as well, that why does this code actually work. So if you actually see, reading, clarifying question, and thinking will take 5 minutes of yours. In the end, you need to have for time complexity, dry run 5 more minutes. So for coding, you only have 8to 10 minutes. So if you're aiming for Mang, you need to make sure that your coding skills are like superb. I'm not talking about algorithmic skills. Your typing and coding skills should be really fast, because you need to code it in 10 minutes. Okay. I've just given you a gist. What Mang, Meta, Amazon, Apple, Netflix, Google, they expect from. That's the reason why they're paid in like lakhs and lakhs and crores and crores. Okay. Cool. We're going to talk about greedy algorithms, how to optimize things, fractional knapsack. We're going to talk about heaps, Dijkstra's algorithm, number of amount taken to cut the ropes in the minimum amount of time. We're going to talk about graphs, number of provinces, MST, bipartite graph, dynamic programming. Okay, so this is the gist that we're going to discuss in the upcoming lectures, so that once the entire course, let's say you have applied for this particular course of data structures and algorithms, right? What me as a mentor, as a tutor, as a guide, my responsibility would be to first explain you whatever the topic is related, the way we start for link list. Next, let's solve problems, because there's no point just reading things, right? Because anybody can read. Third, the thought process, how to arrive to that particular question. Because when we're going to talk about this LRU cache, I told you right in the beginning of this session that I was asked a question similar to LRU cache. So I had to write, imagine in an interview, I wrote 90 lines of code. That is a lot. So, but that in that entire interview, I was asked only one question because it was a really hard question. So unless and until I knew what was the thought process behind LRU cache, I couldn't have implemented the higher version of that, which was asked me. I can't disclose that because I'm bound by confidentiality obligation. But try to understand this concept. You need to understand why we are doing everything. Unless and until you have an answer to the why to whatever you are doing, trust me, you are going on a wrong path. You need to just step back, zoom out everything once again, and then proceed. So I'm here to answer your whys to everything. And the golden rule of learning with me is, ask me n number of times. Stop me, interrupt me anywhere you want. Stop me. Unless and until you understand the thing, don't move forward. Why? Because two things are going to happen. You're going to not understand the new thing, plus the previous thing would be in your mind, and even that's not clear. So, in short, that entire lecture would be useless for you. And be smart, be, and don't hesitate from seeking help. I would be available even after the lectures for some time. And Geeks for Geeks also provides a doubt session classes, where apart from me there's one more mentor who can solve your doubts. There are hours and hours. If you're stuck in a problem, let's say you're solving 5 problems a day, you're stuck in all 5 problems, there's another dot solving guide for you who will solve all. Obviously, I am there, but there's one more assigned to you. So, in short, giving you a crux, as we from Geeks for Geeks, we'll try to give you the best possible thing for a data structures and algorithm, so that by the end of the entire session, you are in a zone that if you have attended all the lectures properly, if you have solved the questions which I am giving you for homework, and you have answers to all your whys, you are ready to appear for any interview from man, and you'll nail all your DSA interviews. Okay, good. So enough of saying that. I guess reversal English we've already done. So now, since I've told everything about this sum of two numbers, I'm giving you this as an homework. So I've already started initiating like how to go about doing things. And odd even list. Let's see what this problem is, and then we'll move to the last and the biggest question, which is LRU cache. Okay, odd even list. I doubt if I'll be able to find this problem on internet. Odd even list. Let's see. Segregate odd and even nodes in a list. Okay, so let's go to the question once. Okay, so the question says, given a linked list of integers, okay, write a function to modify the linked list such that all the even numbers appear before all the odd numbers in the modified linked list. Also keep the order of the even and the odd numbers same. For example, if we take over here, let's say we've got 17 odd, 15 odd, even. So see, even is here, even is here. But the thing that they've mentioned, keep the order as well. So the solution does not contain 12 8. It contains 8 12. That means if the order is 8 12 10, it is 8 12 10 here. Okay. And if you see 17 15, they're moved here. 5 and 1 in the end. So what is happening if you see 17 was the first odd number. Is it over here? Yes. 15 was the second. Yes. So in short, all the odd numbers, all the even numbers, you need to segregate the even to be first, odds to be second, and their order should be maintained as the first one. So think about it. How can you arrive at this solution? So, okay, let's say I am at the interview, right? And I'm given this question. So the first question, reading this, I would ask my interviewer is, okay, sir, what if there are no even numbers? Right? This could happen. So I can write on the same list. What if there are no odd numbers? Cool, I'll write on the same list. What if there is no linked list? Write on this empty list. Okay. What if there are non-integer numbers over here? Okay, Rajdeep. So the interviewer will answer me this way. Okay, Rajdeep, you can assume that it's gonna be a linked list of integers. Okay, cool. So this is the part one. I've read the question. I've asked my clarifying question. The third concept is of thinking. That means how do I come to this particular solution? Okay, so the way I told you, first should be the brute force solution. The first brute force solution that comes to my mind seeing this question is, okay, so what will I do? I'll iterate through my linked list. The moment I find odd number, I'll store in a new list. I see another odd next element. The moment I find an even number, I'll store another linked list. 12 another, 10 here, 5 here, 4 here, 1 here, 7 here, and 6 here. And then I'll just join these two. So cool. So okay, then it's my good habit if I myself tell to the interviewer that, okay, sir, if I am doing this, I see that I am taking time of log of n, order of n, because I'm iterating through every element in the linked list, and the extra space that I am taking is order of n again, because n, let's say half of elements I'm assuming it to be there, so half here, so I'm taking an extra space of order of n. Cool. The solution works, a brute force solution. Does everyone agree to this? Or any doubts for this brute force solution? Anyone? Hi, Adarsh. So, like Adarsh, if you have joined just now, we have discussed a couple of questions. For example, adding numbers to a linked list. This question was finding the kth node from the end of a linked list, finding the middlemost element in a linked list. Then we discussed about how to reverse a linked list as well. Maybe you've skipped all these topics. And right now we are in segregating the even odd numbers of a linked list. Okay. So having done this, the interviewer might say, okay, Rajdeep, is there any other way to make the solution better? I know the time complexity is fine that you are taking order of n. Maybe can you optimize the space somewhere? Okay. Excuse me. this is where I will jump on to a better solution. So let me give you guys still some time. Think about it, and let's see. Think. And trust me, even in an interview, it's okay to be silent for some time. Or even if you're not silent, you can just mum around, like speak your mind. For example, let's say I am at the interview right now. Okay. So giving a vague thought process, what's going in my mind. Okay, if I have to keep the numbers in the same linked list, what I can do, I can have the head pointer for an odd one. So if I have, let's say, first time I see an odd, then an even, then how do I move the even to the first one? That sounds difficult. Okay. What if the moment I see an even number, I keep the head over there, but that's gonna totally mismatch the things, right? So, okay, did you just see what did I do? I was just making my thoughts as an output so that an interviewer can know that whether I'm going on a correct path or a wrong path. Let's say there's a question on graphs, okay, which is a very difficult question, and I am trying to think in a totally different tangent. So that won't help because we got a limited amount of time. We've just discussed about that, right? So how to go about doing that? So since we don't have any text editor over here, I would have just simply told you. So if all numbers, okay. So remember I asked you about a clarifying question. So it's mentioned over here. What if all the numbers are even? What if all the numbers are odd? What to do? So this is the thing that you have to do. Okay. So let's see what Geeks for Geeks provide. The idea is to move to get a point to the last node of the list and traverse the list. Okay, okay, okay. Get a point to the last node. Move all the nodes to the end. Consider all the nodes to move from first to end. Okay, so I feel since there is no place for writing the question, I am just leaving it for you people because I guess we are short with time. So I've given you the brute force idea and how to go about doing this, right? So since there is no practice session, I can't code it over here. It's a homework for you. So let's jump to the best question for today, which is called the LRU cache. Okay. So let me just search for this. Let's search for LRU cache. Geeks for Geeks. Okay. What is LRU cache? Okay, so for those people who don't know what an LRU cache is, a cache system is present in our computer where the cache memory is really very expensive, so it is limited, and we've got a secondary memory. So this cache memory, what it does, it stores the most important things. Now, this importance depends on the algorithm which is implemented. It can be LFU, least frequently used. That means any data present in this memory, if it's not frequently used, it is removed. Why? Because limited space, we're gonna free up space for to accommodate more elements, right? Other one which we're gonna discuss here is LRU cache. Uh, uh, Least recently used. That means any element which is not recently used, just remove that. How to go about doing that? Let's say we have got this particular image, right? Let's say our cache size is 3. Try to understand, our cache size is 3. So there are operations. The operation is to put. That means I'm trying to put a value to the cache. The other option is I'm trying to get a value from the hash. So put and get. And when these values are added using a key value pair. Why? Because let's say the key that I'm putting should be unique, the value can be same as well. Okay, try to understand this way. So this time it was empty. The first time I'm putting the value as a key one value a. What did I say? I have a put and a get operation. So put was key one and a value one, so one is added. I say I add one more operation which is put 2b. So 2b is added. I say put 3c. 3c is added. Now when I say get 2, when I want to get 2, right, it is present in the cache. So this is called a hit. There are two terms in the cache that works, which is a miss and a hit. Cache hit, cache miss. Since whatever we wanted to get, it is present in the cache, right? This key 2 is present. So it's a hit. So we get the value and we can return the value b. But since it is most recently used. Till this time, till the time we were putting the value 3, 3 was most recently used. But when I use this operation of get 2, now 2 is most recently used. So it will come on the top. Now 2 is most recent. Now let's say I say get 4. Is 4 present here? No. So this is called a cache miss. That means it's not present over here. So usually we return a -1 over here. Cool. And the recent things are not changed. Why? Because neither we added anything nor we could get anything. Now let's say I say put 4D. Now the capacity of my LRU cache has exceeded, right? It was 3, now I'm trying to accommodate 4. This is where my LRU comes into picture, which says least recently used, remove that. So out of all these 3, which was the least recently used? 1A, right? Because we did not retrieve its value. We had added and it was added long time back. And it is the least one amongst all these 3. This was the most the one which was recently used, right? So we remove this and then we add the element. But then if you see 4 is added to the top. Why? Because now it's the most recently one, right? So when I say used, LRU, used, use word would be applied for 2 things. Number 1, when you're putting. Number 2, for getting. If you're doing any put or get operation, you need to rearrange your elements. So again, when I try to get put 3 E value, 3 already had a value C. So we're not going to remove any element because we already have it. We're just going to update the value. And once we update this value, what did I say? Put or get. If you're putting, you need to put it to the top. That's what we do. When I say get 4, value of D is returned, and now it's going to move to the top. When I say put 1, now you remember 2 was in the end. So 2 would be removed, 1 would be added. Cool. So this is the rough idea of how LRU cache works. So now somebody might ask me, sir, but why are we discussing this in a linked list, right? So let me just do one thing. If I open practice, okay, cool. So this is the question. You can just consider if you can read, this is a hard level of question. Imagine I was asked even harder question. Okay, so it's fine. You might get hard questions as well. So this is a question which is present over here. So I think I won't be able to code everything for you people because they're short of time today. But I'll surely explain you what the algorithm is, how it looks like, and I will just show you one thing. I guess if I type GitHub, and if I try to log into my GitHub, sign in. If I say it was golden.jmt, let me just type in my password 9349066 capital K small a. Okay, 9349066 golden.gmt. Oh my god, golden.gmt 933. Okay, let me just put my verification code. So it is 601228. Okay, cool. So if you open this lead code thing, you'll see 5 years ago, 6 years ago. So at that time, what I used to do, I used to write the code. And if you just open, let's say, threesome problem, right? Everyone might have heard about threesome problem. I used to just code it over here, right? So that I have my things documented. I think my LRU cache should lie somewhere here. Is it LRU cache? No. Let me just search for it. Maybe it should lie. Okay, no worries. I thought that it was present here, but no worries. So you can do something similar over here too. You can create a repository for you. So this will help you. Like even the interviewers would love to see that you are writing codes in lead code, and it's there here. So see, there are n number of problems that I have done, and it's all written by me. So something similar, even you guys can try. This will help you boost your confidence. Number 1. Number 2, have of self-validation, which is very much important. Okay, so coming back to the LRU question, Cash. Okay, so what do we need? We see that we need a capacity. We have a specific capacity which is given to us. Okay, and now we need to put elements, get elements, but also at the same time we are trying to update the size, right? So what the first thing that comes to my mind, which even you guys should do, is try to understand that whenever we are trying to add any element, it's added as an element of a linked list. So that means we need a node. Okay, this node, and then we have another node. Let's say the capacity is three. Three capacity, one, two, and three nodes. Okay, so what we can do, let's say when we are trying to add element, we add one element, add another element, added, add third element, added. Now, when we want to fetch the value, how are we going to do it? So, in order to fetch the value, we need something else. Another thing could be hash map. So, the two things you need to remember prominently that we need to use here is a hash map and a linked list. Okay. Now, okay. Having said this, how are we going to deal with it? So, how are we going to think that hash map and linked list are the data structures we're going to use over here? The reason why I did not meant to write the code was because there are going to be people who don't understand hash map till now. So, okay, let's do it this way. Let's keep this entire question for my session because it requires even more understanding. But trust me, you can read about this solution at places it is present, how it works. But before jumping into this solution, you need to learn what a hash map is, how hash map works. If you've seen my session, you don't need to think about what a linked list, how linked list works. And over here specifically, we'll be using a doubly linked list. And in the initial stage of this session, I taught you what a doubly linked list is, how to implement a doubly linked list. Okay. So having a doubly linked list and using a hash map, this LRU cache can be done. Okay, so this is a rough session for linked list. There are more things to it, more additional complexities which we would be doing. And in the actual session, once you are enrolled in the course, obviously we won't be talking about like here things. We'll focus on here, like here, and considering everyone's input as well. Why? Because it's not just that I'm teaching here only one or two people. I'm here to make everybody count. And obviously, like if I see that any one person is really slow, I make sure that I will take my time to give you an extra lecture so that the concept is clear. Because I really want each and every individual who is gaining education from me, they should be successful at least in the topics and things that I'm teaching you. Maybe it might happen that there's an experienced person and he says that, okay, can you teach me system design? I will teach you, but you need to enroll in that. But if I have taught you DSA, I can take a guarantee on that particular student that you can ask him any question. He might take 5 to 10 minutes to think about the solution, but he will think about the solution. So cool. Okay, so I think this is enough for like today's lecture. And thank you so much everyone for joining this session. And yeah, if like anybody wanted to know what my background is and why am I wearing a jacket in this hot weather, I'm staying in Bangalore where the weather is amazing. So cool. It's gonna be amazing teaching you people, and let's meet in the lecture. And Geeks for Geeks, it's the best educational platform for, at least I feel, for all the computer geeks. And hurrah! Bye bye.